Okay, so this is 2016 question B1 higher level on intersecting surfaces. The image on the right shows a restaurant which consists of a series of intersecting triangular glass surfaces. Figure B1 shows the plan and elevation of 4 such intersecting planes. Data related to the horizontal and vertical coordinates for points A, B, C, D, E and F. Defining the 4 planes are given. Part A. Draw the given plan and elevation of the 4 triangular planes and complete. So you have to do the given plan of the 4 triangular planes and you have to complete the elevation of the intersecting planes ABCD, ABD, DEB. So 1, 2, 3. So you're not being asked to do that fourth one, which is a common thing students do. Okay, and get confused on. Alright, it's a start because they don't have enough info. So, XY line here on the page, YY line. So, your YY line is an edge of your N vertical plane in elevation and your N vertical plane in plan. Okay, the XY line in elevation is an edge of your horizontal plane and in plan an edge of your vertical plane. So the X coordinates here are how far out from the N vertical plane you go. The Y coordinates are how far up from the horizontal plane and Z coordinates are how far out from the vertical plane. So for the X ones we're going to measure across from our YY1 line. So it's simply a cross. So A is 130, B is 160, C is 100, D is 180, E is 210, and F is 230. So E is 210, F is 230. So that's the position of them after the X coordinates. Now look yourselves, what's the Y coordinate of A? Check yourself. Light line there to position it. So it's 40. What about B? What about C? So B and C are 85. So essentially B and C are on the same altitude, therefore CB is parallel to the XY line elevation. D now. The Y coordinate of D. $30. Okay, Y coordinate of E is 70. Oh, and then the F coordinate or the Y coordinate of F is not given. Now some people will do all them, the Y and Z coordinates in one go, and to be they are correct, you know, it is quicker. Okay, so we're going to go back to A and do the Z coordinate. So what distance down from the XY line is A? And it's 80, so there's A. B is down 35. C is down 35 again. So that means line CB is parallel to the XY line in elevation. D is down 75 from the XY line. So 310, so that's in the wrong position. DE is down 25 from the XY line in plan. And F is down 55 from the XY line. Okay, so I'm going to join all those points together. Okay. So I'll just pause the video and complete them, connecting them together. Okay, so if them connected together as said. Now, the next part of the question, determine the dihedral angle between planes ABC and ABD. So you have to look along the line of intersection between the two planes, which is AB. Now you want to see the line of intersection as a point. And if you look along the true length of the line, it will project as a point. Most students just look along line AB immediately, alright, which is not correct. You actually have to check to see is it a true length in plan or elevation, and it's not, alright, in either, because line AB is not parallel to the XY line in elevation, so it's not a true length in plan, and line AB is not parallel to the XY line in plan, so it's not a true length in elevation. So I need to get the true length of line AB. So what I can do is line up my set square with line AB, okay, using sliding set squares or your sliding t-square. Slide the set square over to point B and A and draw lines perpendicular to them. Now when you're looking at this here, I'm not I don't have my t-square tight against the left hand side of my desk because I'm drawing parallel lines. So you just line your t-square up the edge with line AB, you put your t-square underneath it, hold down the t-square and slide the point. So we just had to do 3 of them. Okay, A, B, C and D, 4 of them rather. Draw in your x1, y1 line that's perpendicular to those points. So this is an edge of the horizontal plane. I just carry on those points a bit, those projection lines a bit more. Now we're going to take our compass now and set it to the height of the points in elevation. So I can put my compass on the XY line, bring the nib to C, lift my compass, follow it along there. There's point C. Now I'm going to do the same with B. So B will be along there, and then I need to do with A and D. So lift my compass there on A and then D. So compass on the XY line, bring the nib to D, lift D. Now this is B1, this is C1, this is A1, and this is D1. Now if 2 points join one view, they join in every view. So A1 joins to B1, A1 joins to D1, D1 joins to B1, and B1 joins to C1, and C1 joins to A1. So this is the true length of the line of intersection. Alright, now if you look along that line, you will get it as a point. Okay, so I'm going to get my set square here, line it up with A1 to B1, put another set square underneath it, slide it over, draw a line there from D1, C1, and extend out A1, B1. Then mark in your x2, y2 line, so it's perpendicular to those 3 projection lines. Y2. Okay, and we're going to take our distances from 2 xy lines back. This is a second auxiliary. It's going to be an auxiliary plan because it's projected from an auxiliary elevation. So you go to get your distances, you go 1, 2 xy lines back. Now there's a lot of space there that we can get rid of here. Okay, so what I can do if I want to save space is to draw a line parallel to the x1, y1 line closer to point C. It's a datum line. It's like moving this closer. It just reduces the amount of space needed over here. So I'll put my compass on the x1, y1 line or datum line, and I'm going to bring the nib to C, lift my compass, find C1 in my auxiliary, follow it down here, mark it in here. I'm going to do the same now with D. So I'm going to put my compass here on the datum line, move the compass to point D, lift my compass, find D1 in my auxiliary, follow it along here and mark in D1 here. And now I'm going to do the same with A and B. So compass on the datum line, bring the nib to A, it's the exact same as the distance to B, lift your compass, find A and B here, follow it along, mark it in. So this is a point view of line B2A2. This is a point view of this is C2 there, and this is D2. And the points join together. And this is the dihedral angle. So you want to label it in and measure it. So you do. So I've written in the angle there, 170 degrees. Now, the next part of the question means it says, part C, draw the elevation and plan of a horizontal line on the surface DEB and then determine the true inclination of the surface DEB to the horizontal plane. Okay, so if you want to see the angle between two planes, you need to see both views as edges. Now, if you want to get a surface to appear as an edge, look along any line that's the true length on that surface. The reason they told us to draw a horizontal line in elevation is because when you drop it down, okay, this will be a true length, okay, and if you look along this true length, okay, the x1, y1 line will be an edge view of the surface DEB. So if you bring B along there and you bring D along there, okay, so this would be roughly D, roughly E there, roughly B. Is an edge view of surface DEB, and the horizontal plane appears as a line here, the HP. So this is the true inclination between them. So, in elevation, I want to draw a horizontal line. It doesn't necessarily have to be from E. Okay, you can do it here if you want. The key thing is that if you do it from here, okay, you drop those 2 points down, look, this one here, down until it touches line B to D, and this one down until it touches line E to D. Okay, that's what's important to remember. Now I'm going to just do it from E, this is easiest there. So this point starts, or this line starts from E, hits the line BD, so you got to bring it down back to line BD. Now, so this is a line here, it's a true length, okay, it's also called a strike. So we're going to line our set square up here, and we're going to look along the true length of this line. Okay, and we're going to project from B, E, and D. And we're going to draw in our x1, y1 line. Thank you, Rupert. Perpendicular to those projection lines. Take your heights from elevation. So compass on the xy line up to B, or you can just plot with your set square because you're given the specific dimension. The y dimension of B, or y coordinate, is 85. E, and then D. So put my compass here on the xy line, bring the nib to D, lift my compass, find the in plan, mark it in there. So got the 3 points there. Okay, that's B1, E1, D1. I join them together here. They should all form a straight line. Now you can extend this down here and extend on your x1, y1 line. Get your set square, or get your protractor rather, measure the angle, so it's 50 degrees here, and say true inclination. Now the next part, part D, says the dihedral angle between surface DEB and surface DEF is 170 degrees. Complete the projections of the surface DEF. So we're going to work backwards. So we need to look along the true length of the line of intersection DE. And we don't have it as a true length yet. So we need to look perpendicular to that line. So I'll just move my visualizer as much as I can. Now, so to do this, part D, I'm going to have to, as I said, look perpendicular to line DE. So I've line 1 set square up, I have a set square underneath it, slide in set squares. Oh. And then x2, y2 line perpendicular to them, or x1, y1 line rather, perpendicular to them, because it's your first auxiliary. Now, here's our x1, y1 line. Keep it close here, keep it close. It'll make it handier for you. So when you're working backwards dihedral angle, keep your x1, y1 line close. It makes your life easier. Take your heights from elevation, as you know. So that's D. Okay, B then. I'm just going to plot them with my set square because you just use the y coordinates given in the first part. It'll be just a bit quicker at this moment. B1. F1 is not given, so you don't know F. F is a question mark. Alright, E was 70, so mark 70 there, E1, and there's D1. So you have D1, B1, E1, and this is the true length of the line of intersection, so you're going to look along that there. And you'll get surface DEB appearing as an edge. So I look along that there, and I draw in my x2, y2 line. Y2. And you take your distances back from your x1, y1 line back. So here's D. So I follow D along here, and E will be the same, so that's D1 slash E1, and B1. And there's B1, and I can mark them in. Now, it says the angle between them is 170 degrees. So watch this. I'll put my protractor here on this line, and I mark that there. So this is a possible way for the angle. Okay, this is one possible way. Possible solution 1. Or you could go to that was a little inaccurate there, sorry. I'll do that again. So point F could lie somewhere along that line there I've just drawn in. Also, it could lie somewhere along this line I'm about to draw in. I'm marking in an angle of 170 degrees here. Okay, that's 170 degrees. And so is that, just going the opposite way. And this is a possible solution it could lie on. Alright, so it can lie. I'm going to zoom in right here now. So to lie on one of those two solutions. Now, if we had f in this view, it'd be this distance away from the x1, y1 line. So what we will do is take our compass, put our compass on the x1, y1 line, take that distance from the x1, y1 line to f, lift your compass, alright, mark it in along here, just any projection line. Alright, mark it in there. So your compass on the x2, y2 line and mark it along any projection line. Now you draw a line parallel to the x2, y2 line because it always has to be that distance away. And this is, look, this is your possible position for f. Okay, the question is which one is the correct one. Alright, and the way you find out is you bring this back to your first auxiliary. You project backwards to it, and it should be the answer 1 or 2 has to be on this projection line from f. So you slide this back here. Now this could be a possible answer, so that's a possible answer, and this one could be a possible answer as well. Alright, but the question is which one is right. Okay, now how do you figure out? Well, this is an auxiliary elevation here, and it contains the heights. Now, you take your question sheet here, and you look which one is closer to the xy line. Okay, so a possible position there for f would have been, from our sheet would have been this one, 2, or this one, 1. And clearly, this is the answer. So, over here, this is the position f1. You can join them together, and then you just take the height of f1 from your auxiliary elevation with your compass, lift with your compass, find the f in plan here, mark it there onto your xy line. Just slide my projector back, or my visualizer back, and then I'm going to join F to E, E, or F to D, and that is the question complete. So I'll zoom out here. And that's what it looks like. Alright, cheers, thank you, bye bye.